Good evening, everyone. We are talking about the project sentiment analysis on Yelp reviews. We have used big data technologies about which we'll be talking through this throughout this video. Uh, Once again, yeah, everyone's able to see my screen, right?
Yeah.
Uh, So we have five in this group, me and Bud. Then we have Mahesh, Sai Krishna, Karthik, and Supraja. Our project mainly focuses, our main focus is on finding out what is the customer sentiment when he's posting a review on the Yelp platform. We have took advantage of Yelp real-time API. I mean, we have used Yelp API to take the real-time data and also use the historical data, which is close to 9 GB for our training of the model. This is our system architecture where we have extracted live data from the Yelp API and pushed it into PubSub. And from the PubSub, we have pushed it into BigQuery. Simultaneously, we also took the Yelp historical data, which is a huge data set, which covers the volume aspect of the big data. Uh, and we uploaded this historical data into the Google Cloud Storage. And through this Google Cloud Storage, we have used BigQuery as our data warehouse, and all the programming is being done in the Dataproc platform, and the data preparation was also done in the data preparation and modeling was done in the Dataproc platform. And after testing, the final result is again saved in the BigQuery. And for reporting and visualization, we have used BigQuery. This is the methodology that we followed in our project. Data collection and data storage was done later, and data processing, feature extraction, model development, and model selection. I'll be talking through each of this in the successive slides. So about our data set, the API allows us to pull 500 reviews each day. We have pulled 500 API Yelp reviews each day for over a period of time, which is pulled through the Dataproc, PubSub, and it is saved in JSON file in the GCP folder. And we also have the 9 GB JSON formatted data set, of which we have used Yelp business JSON, business review JSON for our model development. And our data storage is done in the GCS bucket. We have PubSub and BigQuery, where the real-time streaming is done in the PubSub, and BigQuery, where our process data is stored. Data processing. There are two data processing happening in our project. The first one is the processing of the live data which we are getting from the API, and also the data that we are using for our model training from the historical data set. Mahesh will talk about the live API processing.
On the live pre-processing that we're doing on Help, so when we call in the Help API, we get the raw JSON format, which is not applicable for any processing or even to build a model on the raw data. So for that, first we take the raw JSON file with the help of Spark. We uh, take down the words, we remove all the stop page words and we convert all the reviews into lowercase values so that it will be uniform for the modeling. And then we completely store all this data in a data frame, which will be further used for the testing of the machine learning model that we create. Next slide.
Yeah. The feature extraction is being done from the historical data set where we take only the text column of our data set and we tokenize it, then we vectorize it and we capture those vectors and try to train our model. We tried single vector SVM, logistic regression and naive Bayes. Initially, our models had very less accuracy, so we had to do hyperparameter tuning. And once we just after tuning at the evaluation phase, we found out that our model had heavy bias because of the imbalanced data set, and there was also s- what is it called, signs of underfitting. So we had to train the model on the whole data set, and upon training we found out that SVM had the highest accuracy, somewhere around 95%, whereas naive bias gave us 61% and linear regression also gave us 62% accuracy. Once the model was trained, we the live API data, whichever was pulled, was ran through the model, and the prediction was saved in a BigQuery. As you can see here, we have the predictions. These predictions are done on the text, and we did find out there are few false positives and negatives, but on deeper analysis, we did find out that our model was more accurate as it was strictly predicting on the text. And sometimes there are cases where the customer's text or reviews were negative, but the ratings were positive, and the other way around. Finally, our model deployment was done on GitHub. These there were many challenges throughout the implementation of the process. Some of them are uh, doing the whole process on a Spark ecosystem and using Spark PySpark ML libraries. And there was also issue with model training, and some of the models took us more than 48 hours to give an end result. These are the some of the top words that we found upon running it. As you can see, pizza is some of the top words which had very high. Most of the reviews had mentioned pizza, and the same word pizza was also found to be more in number in the negative words and also the positive words. And text processing was and the total number top words in the whole process are this, where we have pizza slices and all to be more common. Thank you.